Thanks, Tim. Hello, hello, hello. Morning, everyone. Thanks for some of you I've recognized from yesterday coming to my Angular workshop. It was good to see you. Had a good day. Coffee's in, ready to roll. Hopefully everyone's awake. So today we're going to be sort of taking you on a bit of a journey. From 1994, when I was about 3 or 4 years old, all the way until now, we'll be looking at how Angular kind of overlaps with some of the web APIs that are coming, help us deliver stuff that's coming in the future now. So, a bit about me, just a little picture. So, my name's Todd. I work in Swindon, which is just over an hour away from here. It's not very glamorous, but it's not as glamorous as London. So, I head up the front-end team at a Google Enterprise company. We've been building Angular applications for about 1.5 years now, kind of keeping it as our main toolkit on the Google side, on the front end. So yeah, that's me. And what's happening today? So we'll have a look at the web from pretty much its beginning to, I say the end, but right now. So yesterday, where we came from, we'll be looking at tomorrow, where we're headed, all the exciting things that are kind of approaching us. We'll look at today what's already available, things like HTML5 APIs that we start to use every day. And then where Angular kind of fits in the picture. So where is Angular today? And some of you who use Angular, hopefully, will be following their continuous development. There's Angular 2.0, which is sort of in active development. It's being written in a language that can't even run in a browser yet, so they're really, really pushing that towards the future. So let's rewind, have a look at the past. I'm waiting for cringes on this next one. We're all used to these tables, or at least we were. I've put them in capital letters so you can all get a bit nostalgic. And things back then were very declared. I mean, we used widths and cell paddings, and if you wanted another table, you've then got to copy and paste the exact same stuff. We got to replicate all the attributes, and things get a little bit messy. Some of the favorites, we got the blink and the marquee. These were probably the most dynamic and exciting elements of the time, and this was a long, long time ago. Some of you may see this one that dotted around the web still. Hopefully nobody in here is writing the center tag anymore. Font size 4, I mean, we use CSS for this stuff nowadays. We wouldn't even think about doing this. And then one of the worst ones, my favorite, inline sort of JavaScript, where we make things nice and global, WW1 and all that kind of old stuff. Hopefully everyone's remembering their childhood now. And then one of the best, we had the map, which we could make images really, really cool, and suddenly we've got hyperlinks to these amazing things. And what did this technology give us? An incredible website. So this is Microsoft's first website in 1994. They've actually put it online not too long ago, so it was perfect timing for this talk. The whole thing was made out of actually that last code snippet with the map and stuff. So you kind of think about back then, we've come a long, long way. And 11 years later, surprise, surprise, we didn't actually get a lot further. YouTube's first website, 2005, which some of you, it looks a bit like a Dreamweaver template. It wasn't great. So where are we now? We've got the mystical, powerful logo of HTML5, which to me says a great deal about where we're at. I mean, it's a powerful kind of emblem. HTML4 could have done with a logo, but it probably would have looked rather shoddy. So what does HTML5 give us? We got video and audio. We got WebGL, Canvas, things that we used to do in like Flash and now sort of native to the browser. Got get user media. We can access webcam. Geolocation, brackets, kinda. IE8 supported geolocation. It's kind of in the HTML5 umbrella, but it's not really there. The full screen API, we've got WebSockets, local and session storage, we've got the history API, IndexedDB, WebSQL, another kinda, native form validation, although it's not really one of my favorites because they're very inconsistent across browsers. The form data API, serializing forms. We've got data sets, so custom data attributes. I'm sure everybody's had to play with those. HTML5 semantics. We've got all the new elements like header, section, article. We've got the file reader API. If you're probably creating an upload widget or something, you're going to be using that. We've got the class list API for adding, removing classes, jQuery style. All these things kind of inspired all these new technologies. We've got the drag and drop. We've got events, and post message, and content editable, which is just a simple attribute that makes things editable. And breathe. HTML5 is pretty big. So back to day one at Microsoft's first website, and you compare the stuff that we're using now, it's absolutely massive transition. And to make things even more difficult, we have frameworks, not libraries, just frameworks, MVC and VVM. And what does that look like? I'll put Angular at the top because it's my favorite. We've got Angular, we've got Backbone, Ember, Knockout, and React, which is more of just a V rather than MVC. But why do these frameworks exist? So we're still missing a lot of things. We kind of are, kind of were. Templates, encapsulation, and components. Two-way data binding with model data. We're missing promises, class-like components. A lot of these frameworks like React, Backbone, are kind of bringing in that class-like components. We're missing modules. So ES6 is going to be bringing modules to JavaScript. And dependency injection. If anybody's used Angular, you'll be used to the dependency injection, how that works. So where are we going? There's a lot of exciting stuff on the way. Web components, HTML5. Who's using web components today? Nobody, exactly. So there's the Google team are actually creating something called Polymer, which it's kind of a polyfill for the web component spec. I think Chrome is probably the best supporting browser at present. But web components allows us to do a lot of things that we've been wanting to do in a long time. Sadly, being on the web, we all have to wait for these technologies to be delivered and catch up, otherwise IE doesn't support it, and we end up with a headache. We've also got object.observe, so we've got native model watches. We can get events passed to us when things change. We get a list of changes. We get native promises. If anybody's using stuff like jQuery, you've got success and error handlers. .success, .error. We've got .then if you're using Angular or any other promise library. These things have been thought about and now are coming actually to the web. Modules in ES6. We'll be looking at some of these code examples as well. And finally, classes. I think classes are kind of a bit undecided on whether they're a good thing or a bad thing for JavaScript, but we'll see. So web components, let's have a look at what's coming for web components. Later we'll be looking at how Angular as a framework helps us deliver these upcoming stuff now. Maybe not in the exact way that they're intended, but the concepts underneath are exactly there. So this is probably my favorite example, the Google Map element. So the idea behind these is that all the logic and underlying libraries is all encapsulated in the Google Map element. What we then do is just import the element and declare it. And we can pass in a latitude and longitude, and it will generate a Google Map. If you think about how you use a Google Map before, you might copy and paste a load of code. You've then got a huge, like, hello world to even get a marker up. So we just completely abstract that, and we can pass in these attributes. And the same with the Google Map marker. So we can then have a custom plotted marker. So the center of the map, and then the marker wherever we want it to go. Templates in web components. We got introduced, hopefully everybody can see that. We got introduced with the template element, which if anybody's had a play with, you'll probably notice that you can't see anything. I first used it, and I was like, well, where's my code? Template's actually invisible. It's display none by default. If you right-click View Source, you can then see everything inside the template element. And the interesting thing here is we've got full encapsulation and full scoping. You see I've got colon and host. What the host does is refer to the root element of the web component template. We've got map inside, which has just got a simple div. These are very simple examples, by the way. Is my clicker stop working? No, there we go. So ShadomDOM. ShadomDOM is a little bit strange to get your head around at first. What it effectively is we're all used to the DOM, the document object model, which when our page renders, we've got this live DOM, stuff is generated, things are all parsed out. And what ShadomDOM allows us to do is use these template elements, and they get injected into like a placeholder. So we look at a Google Map element, and all the stuff that we created in our template is then injected. And these white pieces of text and the arrows, they actually is what you would see in like Chrome developer tools. So they represent the shadow DOM. So the Google Map element, for instance, with the longitude and latitude, that would be in the initial DOM. What gets injected in what we call the shadow root is the shadow DOM, which is like a nested DOM tree. And you can have shadow DOM within shadow DOM within shadow DOM, and people make quite a few jokes about that. HTML imports. If you're used to client-side or server-side JavaScript libraries, you might be doing imports. So HTML kind of thought that might be a good idea. Some people have written some articles on whether this might be a good thing, might be a bad thing. I'm not too sure yet because no hands came up with nobody's using it. We haven't gotten a formal opinion yet. How this works, taking the Google Map example, what we would do is in the head tags of our web page, we would just do link rel import and then the href to our component. That then allows us to use the component multiple times, and it just gets instantiated. Let's look at ES6, object.observe. These code examples are from HTML5 rocks. If you're interested in, ignore the fact that the link says ES7. If you're interested in all the JavaScript APIs, then I highly suggest checking out HTML5 rocks. I think it's a Google sort of funded project. Absolutely fantastic. So Object Observe, I think it's landed in Chrome recently, maybe Firefox, I cannot remember. What it effectively allows us to do is watch JavaScript objects and watch for changes, which is usually done via either like dirty checking or something that another framework would do. Angular uses dirty checking, which stores all the object values, and then once something changes, it runs something called a digest cycle. So the digest then loops through all this object again and checks for changes. This is a huge, huge performance bonus. It's all native. It's only does it when there's no digest. So Angular will be incorporating this kind of stuff in the near future. Promises. We looked at promises earlier with, well, we didn't actually look at them. I mentioned them earlier. jQuery had like a success or an error. Other libraries such as $Q, which Angular use, they always used like the then, and everything's becoming a bit more promise-based. And now we got these, another HTML5 rocks example, which we can just call new promise. It's a constructor. We can resolve things or reject them inside. And this is pretty big for the web. I mean, the performance increase on these is going to be a lot bigger, a lot better. I mean, you might not be using these APIs completely natively. There might be some kind of wrapper around them. Modules. So modules are quite strange. There's the concept of export and import modules, and then there's also modules where we can encapsulate different sections of code, such as like an authorization module or a dashboard module, and import them. ES6. The modules here, thankfully this was a nicely timed post. This came out this month, actually. This was the final syntax for ES6 modules, so I had to update these slides. This is really, really smart. If there's any back-end developers, you'll probably recognize some of the syntax. If you're a front-end JavaScript developer and haven't seen modules, you might think this looks quite strange. In effect, we've called it lib.js, so we'll have a couple of functions in there. What we'll then do is export something called square. We can export diag, should have put gram on the end. And then in main.js underneath, we can then import them from lib. And it makes it really, really simple. We don't have to worry about the execution order of the code. Es6 Classes. Jack will like this one because it's got his link in it. So Jack wrote this article on JavaScript Playground. I would check it out if you're interested and haven't seen JavaScript Es6 Classes yet. This kind of simplifies the whole object and instantiation. It's more syntax sugar over the kind of prototype approach. So where is Angular? We looked at how custom elements are coming. They're not quite here yet. I mean, IE is still under consideration. So using a framework might be a good choice. We can create a custom element, a Google Map element in AngularJS. We can pass in the longitude, the latitude, and as a concept, it looks exactly the same as if we're using real web components. Nobody knows. The way that Angular does templates, some of you might be squirming at the templates in a string. Angular, this is just one way to use a template in Angular. There's actually 3 ways. When JavaScript libraries first came out, there was a whole thing about, I think jQuery was one of the first to do it, putting templates in script tags and changing the MIME type so that the browser didn't render it. And then what you could then do is like instantiate that and use it as a reusable component. We've also got template URL, which Angular uses, which can go and fetch and import. For simplicity, though, we'll look at the Google Map. It's the same code as the web components example. Angular calls these directives. So at the bottom, we've got .directive, and I just pass the Google Map function in. You'll notice that the M in the directive has a capital. What Angular does is translate the capital in the directive name to a hyphen. So if you want two-word element, that's the way to go. The ambiguous Shadow Dom, in quotes, it's not quite Shadow DOM, but the concept behind it is kind of Shadow DOM. We've got a Google Map element. So there's no white arrows, there's no shadow root in this. The concept is it just injects the template that we want. So we've got the div class map, the div ID is map. This is our template, and then I'm just assuming here that Google, the library's included somewhere. It's rendered the canvas, and off we go. HTML imports. So the web component spec is a little bit different. You can have nested imports within imports. Angular makes it a little bit easy, and we don't actually have to do all these imports. Mentioned template URL. So this can go and fetch a specific import from somewhere. Interestingly, Angular, think about this. If you want to make a get and go and get a directive reusable component, it doesn't just keep, if you've got 4 of them on the page, it just won't make a get, a get, a get, a get. What it does is it makes a single get, and then it puts in something called the $template cache. With Angular, you'll say the $ word about 10 million times. With the template cache, what it does is caches the template. It stores it there until it needs it again. So it's thinking about performance. We'd normally have to write code around that. So we're going to make the get. We might create an object and store the DOM in there. Angular, we just glosses over that. It does it all for us. It makes it super simple. Scope.watch. This is probably one of the coolest things in Angular. It's actually inspired the object.observe. So the fact that we keep building all these brilliant frameworks with all these functionality are actually kind of suggesting that developers are building the way forward for the web, and it's not all about like the W3C and all these specifications that are being written. I mean, we're all building things that contribute to the future. So scope.watch, it's a little bit simpler to use than object.observe. We probably, when object.observe is around, we probably will be using something like scope.watch anyway. It will just be the underlying changes that are being observed via object.observe. And the interesting thing here is you can watch anything you want. You can watch an array, you can watch a string, and Angular will just pass you a new value and an old value. And then you can execute a function and do something else with it. So Angular promises, not the most exciting, but to have promises inside a framework is pretty cool. And you'll see we use something called $HTTP. HTTP is one of the internal Angular back-end sort of communicator They have something called $resource as well, which you can use for more REST-based APIs. This is a simple example using a get. So we hit /URL. If any people sort of use Node quite often, you'll use then and you'll pass in response and the reason. I prefer this syntax over the .success and .error. It just seems a little bit cleaner, a bit more promising. There we go. So above and beyond the specs, we talked about things that were missing from the web platform, things that templates, frameworks do to help us build. So Angular gives us dependency injection. Dependency injection in JavaScript doesn't quite exist. And what it does, you'll be interested to know. Any Angular people will obviously know this, so you can switch off. Scope and root scope, we're not actually going to be calling this with any pointers. We're just going to be declaring. We're saying, I want scope and I want root scope. These aren't function arguments as such. When main control gets instantiated, Angular actually converts function main control to a string. It uses a couple of really clever regular expressions to look at what's in those function arguments. What it will do is then say, I need $scope, I need $root scope, and it goes off, gets the providers, instantiates them, injects them into the controller, and then we're free. If we were to use $scope inside the main control and remove it from the arguments, we'd get an unknown provider error. It just helps with passing objects around and only declaring them when we need them. One of the things that's very, very powerful about Angular is the declarative bindings. So instead of writing a lot of JavaScript, I mean, I came from a background of writing websites, and I used to get bored with the amount of junk that I would write trying to do the same thing in different places. With the bindings, they're very, very clever because with the ahref ng-click example, we just declare an ng-click. It binds the event listener for us. It listens to it. We don't have to write add event listener. We don't have to check for IE, attach event. We don't have to do any of that. We don't have to include another library. We've also got things like ng-bind, ng-controller. ng-bind will bind the model value to a specific element. It's just an alternative to the double curly handlebars that you've probably seen. ng-controller tells Angular where in the DOM I want a controller to control. So much like JavaScript scope, where you've got different functions which have different scopes, the DOM works in the same way. So if we've got a div with a controller here and a div with a controller here, the data in each one won't be accessible. So their scope is quite hard to get your head around at first. A lot of people call it scope soup when they first start with Angular. This is probably the most powerful thing in Angular is the ng-repeat. The repeat is very, very clever. It allows you to just create one element and then it gets repeated based on a data set. So if you're familiar with building websites, you probably built a navigation before. The client says, oh, I need an about navigation item. And you're like, oh, I've got to go and change it now. Then they want to change a word or they want to change an icon. You have to change it for each one. The idea here is that we just have a list item. Obviously, this would be full of code and you just repeats it as and when. But the idea here is we've got a list item and vm.users, which VM stands, it's just an object namespace for view model. The users will assume is an array. The array will get looped over and repeated for each item in the array. We use an alias of user, so user in vm.users. We use that user to get each stamp, each clone of the DOM access. JavaScript objects as DOM. If you've ever used Knockout.js before, you'll notice that you're binding JavaScript objects directly to the DOM. Whereas if you're using like a framework like jQuery, you don't kind of get this this benefit. What Angular does is allow you to have a JavaScript object, and for example here, we bind it to an input type text. What that means is no DOM querying. We don't have to use something like jQuery or use a dot value. We just tell it, we just pass things the model value. So for instance, if this was somebody updating their username, all we would do is observe the model change. And you might have a button underneath that says update username. The user can click that, and all we send to the server is vm.someModel. We don't have to query the input. We don't have to do anything more difficult. Angular expressions, these are inspired by server-side languages. You'll notice user.notifications.length. The length's pretty interesting. There's a lot of other operators you can use. You can use ternary operators, the double and, the or. And what these allow you to do is conditionally swap out either text or HTML. They act as placeholders for data, so you can see underneath user.name. It doesn't need to be hard-coded. It means we can reuse these components. We can have a small component for a user and a notifications, like if you log into Facebook, it's got your name and some notifications at the top. The idea, just a simple demo, it's going to log out my name. Facebook might not want to hard-code everything, which probably wouldn't be wise. So we then have the notifications.length. We can click on that and go somewhere else. Automated events. This is very, very powerful. So we just declare an ng click, and things get bound for us. We looked at the ng repeat earlier. You might have an ng click inside the repeat. Instead of binding 10 different event listeners to each one and working out which one was clicked, what we can do is just declare an ng click. Angular will bind it to each one of those for us. We can then access things like $index, so we don't have to work out which item in the array was clicked. We can remove things from the DOM with ease. Component life cycles. We've got automatic event binding and binding, which I just mentioned. The creation and destruction of the DOM and the scope model data. If you're building single-page applications, such as Gmail, you're going to be clicking on the settings, and then you don't get a full page refresh. You just get the middle content, which dynamically changes. What Angular does is use something called a watcher. Every scope and piece of model data creates a new watcher. It gets added to what we mentioned earlier, the digest cycle. So every change that happens, Angular will loop through this digest cycle. When you change a view, specific parts of that digest cycle get destroyed. So if you've got a load of emails in an inbox, you've got probably a lot of watchers. If you click on the settings page, you're not going to have all those watchers, all those scopes. So Angular will destroy that for you, and this helps with app performance a lot. ngIf, if you've used Angular and you've probably used ngShow, ngHide, ngIf is actually the more performant option. What it does is recreate and destroy the DOM based on the true or false value. Angular routing. So I don't think the web will ever have some kind of native routing, but it's what every application needs, unless we're sort of rendering things server-side and doing full page refreshes, which can be a headache when mixing languages. So Angular gives us an external module called ng-root. This root module gives us $root provider. All we do is inject it. We can declare, when we're at /inbox, we're going to serve up mailbox.html. We're going to use a controller, inbox control. We saw earlier you can use ng controller on the actual div itself. This way you can do it dynamically, so you can have multiple views using different controllers. We've also got dynamic routing. So, excuse me, when you go to /email, we've got a :ID. When you load up a Gmail, an email in Gmail, you get like an encrypted ID in the URL. This will change dynamically, but you'll still get the same content. You get the person's image and their response to you. So this allows you to do that similar kind of thing. Instead of hitting a 404, we've got an otherwise, and then we can redirect to the inbox page. Modular JavaScript. So Angular is very modular, or it can be if used correctly. Instead of creating an app all in one namespace, what we tend to do is build like feature-driven modules. If you're using like an auth module, for instance, or a growl, which if you're using a Mac is the notifications, so we sometimes use those as app notifications. So the auth module, we might package separately. We might reuse it in multiple applications. We don't want to have to keep digging through all my directory structure, trying to pull out the bits that I need. If you keep things modular, and then you can import them like this. Angular modules have a setter and a getter syntax. So the setter is the example here. You'll see the second argument is an array. That says I want to create the module app, and it has these dependencies. And the auth module, that would obviously be angular.module auth, and that might have dependencies. So you can have this nested layers and layers of dependencies. In JavaScript, we can't really do that. Form validation. We do a lot of forms where I work currently, workflow forms, and this kind of builds on top of the HTML5 spec. So Angular listen to all these forms, like what's happening with the form for you. They give you something called pristine, which means that the user hasn't touched it yet. Dirty, which means that they've touched it, and they might have, not like that, they might have entered some data. They also have invalid, so if you say the string length needs to be 3 and they've typed 4, you would then have $invalid as a class name. We've also got valid, which is obviously when it's valid, and error when there's an error. So the other thing that Angular has recently introduced is something called a pattern. For those who follow the HTML5 form specs, you've got something called the pattern attribute. We've got something in Angular called ng-pattern, so you can provide it a regular expression, and it will validate it on the fly. So if you need to enter a credit card details, as the user's typing, it's checking that it's pristine, it's dirty, it's invalid, it's valid, and you get all this live feedback, which is a lot more powerful than the HTML5 APIs. So where next for Angular? If you're interested in all of that and probably want to look where Angular's going, a lot of the 2.0 stuff I've looked at, and it is very complicated. Some of it's over my head. Follow the bit.ly URL. They've got a Google Drive, and this is the brilliant thing that I love about the Angular team. Everything's public, so you can see what they're working on. You can see all the discussions. So a couple of things before we finish. We have faster change detection. I mentioned, the object observed, which is coming in ES6. They've got something called Watchtower, which, if anybody's heard of Google Dart, the new language, one of the algorithms in Dart was ported across to ES6. That'll be in the new Angular version. The template engine. So at the minute, directives, as you saw before, they're very sort of function-based. Why? I've started toying with the React Facebook framework, and they're using something called classes, React class, and you just pass it an object. This is kind of where I think Angular are looking at going here. So this, I spoke to Brian Ford, who heads up, well, he's one of the core members on the Angular team. He said this is not quite what it will look like, but it's possible it might look something like this. Data persistence. The web's kind of going offline, service worker, as we all saw. ng WebSocket, so we're getting all these wrappers that Angular are building for us. Some of these APIs, such as Safari, one of the API, I can't remember which one it was, one of them doesn't work in Safari, and Angular just polyfill it for us. I mean, it's brilliant. We can start using these reliably. They've got how many unit tests to fill a room for each of these modules. So the beauty of it is they're very, very secure. They're very well tested. We've got ng store. It's a wrapper, just a thin wrapper around local storage. We've got local DB, which is the same. We've got ng offline. Service worker's not here yet, but Angular already working, thinking about how to bring it to us. Dollar connection, which I'm not quite sure what it is yet. ng data, so these are bringing sort of data models to Angular a bit better. And ng HTTP, instead of having a $HTTP and a resource modules, what we'll do is keep them under ng HTTP, and we'll make them more data-focused APIs. Angular annotations. So you might be wondering what the @ sign is. I think this is a way to do the dependency injection. You'll notice that the word Angular doesn't exist. There's no Angular.controller, no Angular.directive, and then you pass in the mock heater. And the idea is that this hides the wireframe of Angular, reduces the boilerplate. We're nearly there. So the takeaways from today: Angular helps us deliver the future now. We've looked at where we've come from, where we're going. 2.0 in Angular, they're very, very fast-paced development. They're thinking about it already. I don't even think about the future already, but these guys are already on it. Frameworks will always be ahead of the web. I think some people would say the opposite, but we probably wouldn't be where we are today without frameworks and libraries. Even libraries like jQuery. I mean, they've helped build something like the class list API, but probably wouldn't be as elegant if jQuery didn't exist. Where next? I don't know. I'll see you there. Thank you.